with an insight into various simulation models and knowing that INET simulation framework provides the basis for building subsequent new protocols, it would be a good exercise to have a walk through the processing of the protocol and its operation in the INET simulation framework. For that, in this module, we are going to have a look at the basic operation of the address resolution protocol, namely the ARP. We are going to see how INET implements it, and then we are also going to look at the details of how ARP works, the packets that it uses, the tables that it updates, and the queues that it builds. One could wonder, why choose an ARP scenario? Because after all, ARP sits at layer 2.5 and it is not one of the most well-known protocols of the TCP/IP stack. True, but it is equally interesting to observe that ARP provides us an interesting relationship not only with the protocol operation at the data link layer and the network layer itself, but it also establishes an interesting relationship with the higher layer protocols. The URL which is highlighted here on the screen is actually the Omnet++ website where the code, the NED file, the C++ files, the message files can be found for the scenario that we are going to understand. The scenario that I've chosen to have a walk through the operation of the INET simulation library is the ARP scenario, but ARP scenario is not triggered at its own. ARP protocol starts working when it needs or when it is given an external trigger, which comes from the upper layer, that is from the application layer, the transport layer, the network layer, and then the data link layer where the ARP works. If we look at this scenario, we see that we have a client PC that wishes to open a TCP connection with the server. Now, the client and the server are few hops away. In this case, the client has to first establish a TCP socket through the IP address. The TCP socket activates the network layer. The network layer subsequently asks the data link layer to retrieve the MAC address, because in this scenario, the client cannot send data or open a TCP connection directly with the server. It has to do this through router 1. So it is going to forward the frame which will carry a packet destined for the server, but the frame would be bound from the client to router 1, from the router 1 to the routers in the upper part of the network, that is any of the routers 5, 6, or 7, and then to router 8, and then to the server. So it means, as we know the operation of switching and forwarding, the MAC address is going to be discovered and changed at every hop, and the IP addresses for source and destination are going to remain unchanged. When we look at the INET simulation framework, you can also look at the SourceForge Mixim website. You shall see that ARP scenario uses ARP protocol, which subsequently calls other C++ files, other libraries. From a network perspective, ARP uses Etherbus standard host, the Ethernet line itself, the IP version 4 network configurator, and the router. All these are compound modules which are used in this ARP test scenario. Before actually we see the ARP protocol at work, we see that when we run the simulation in TK environment, the first thing that happens is there is an auto configuration that takes place at the routers and some messaging takes place. Since a router is implemented as a compound module that subsequently uses other compound modules, the complexity and inner working of the auto configuration procedure is skipped here for brevity.